Hey, so we have this problem and it says simplify this expression. And our expression says square root of 128 x to the fifth power. All right, so the first thing I'm going to do is I'm going to look at 128 and see what that factors into to see whether or not I can pull some stuff outside of the square root. So 128, I see I can take a 2 out. I take a 2 out and I get 64. I can take another 2 out. I get 32. I keep going. I can take out another 2 and I get 16. 16, that's 4 times 4, and 4 is 2 squared. So 128 can factor as 1, 2, 3, 4, 5, 6, 7. So 2 to the seventh power. All right, so I'm going to plug that in for, I'm going to reduce this 128 and write it as the square root of 2 to the seventh x to the fifth power. All right, so one thing about square roots, whenever we have the cth root of a to the c, we get a. So I can split this up into two square roots. If I had square root of b times c, this is the same as the square root of b times the square root of c. So I'm going to use that property in this next step, and I'm going to break it up into the square root of 2 to the seventh times the square root of x to the fifth. All right. Then from here, I can group these 2 to the seventh and x to the fifths in twos, because every time I have a squared term, it's going to cancel out with the square root. So what I can do is I'm going to group this 2 to the seventh by powers of 2. So 2 squared times 2 squared times 2 squared times 2 to the 1. And I'm going to do the same thing with the x to the fifth. So my x to the fifth, I can factor it as, use a different color. My x to the fifth, I can factor it as x squared times x squared times x to the 1. This is because of the property where if I have a to the b times a to the c, this is a to the b plus c. This works both ways. I can start with something x like x to the fifth and factor it into stuff that adds up to 5. Or if I have stuff that is being multiplied, I can add up my exponents. It works both ways. So now I'm going to rewrite using all of this that I'm circling here. I'm going to rewrite that as, I'm going to rewrite it here, 2 to the seventh square root x to the fifth. I can rewrite this as the square root of 2 squared times 2 squared times 2 squared times 2 to the 1 times square root of x squared times x squared times x to the 1. All right. And then I can use this property right here that I'm putting this star by and circling. I can use that property again and break up all of these square roots. And I'm going to get the square root of 2 squared times the square root of 2 squared times the square root of 2 squared times the square root of 2 to the 1 times the square root of x squared times the square root of x squared times the square root of x to the 1. And then I know that the square root and the squares are going to cancel each other out, and I'm just going to be left with whatever was being squared inside my square root. So this is 2 times 2 times 2. This square root of 2 to the 1, I don't have a squared term, so I have to keep that square root of 2 to the 1. Alrighty. Then square root of x squared, I'm just going to be left with x times x. And then in this last one, I have square root of x to the 1. That x to the 1 wasn't squared, so I have to make sure I keep it in my square root. Now I can group things and move stuff around. I'm going to collect these 2's, and I'm going to have 2 times 2 times 2 is 8 on the square root of 2 times x is x squared on the square root of x. I'm going to move these around a little bit more, make it a little bit prettier. 8x squared times the square root of 2 times the square root of x. And then I can use that property again that said square root of b times square root of c equals square root of b times c. I can use that again, and I'm going to get 8x squared on the square root of 2x. And that would be my final answer. So what we did was we try and factor, if we have a number here, like right here we had 128, we try and factor that into like multiples of something squared so that the square root and the squared will cancel each other out. That's what our goal is for these, is we're trying to cancel out some stuff using the square roots and the squares.